Hello everyone, welcome back to the SQL Server video series. My name is Debarchan and I work for user education team in Microsoft for SQL Server integration services. Today I'm going to show you how we can leverage a new SSIS transform component called the balanced data distributor to reduce the execution time of an SSIS package. This video assumes familiarity with the basics of SSIS package and the different data flow components like the data flow source, the data flow transform, and the data flow destination. The Balanced Data Distributor, or BDD, is a new SSIS transform designed to take advantage of concurrent processing capabilities of modern CPUs. It does not have any configurable options, and it takes a single input and distributes the incoming rows to one or more outputs uniformly. It is to be noted that the use of the BDD component is beneficial, particularly in a data flow which has slow performing transforms within it. This transform takes one pipeline buffer worth of rows at a time and moves it to the next output in a round-robin fashion. It works synchronously. So, if one of the downstream transforms or destinations is slower than the others, the rest of the pipeline will stall. This transform works best if all the outputs are connected to identical transforms and destinations. Our main use case scenario will be with situations where the destination is slow in general and also where there is a room to take advantage of the parallelized inflow of data, typically like SQL parallel data warehousing appliances. So this essentially means that it is intended to be used to store data in a single underlying target, for example a database table. This BDD transform component as of now supports SQL Server 2008 and 2008 R2. The BDD transform component can be freely downloaded from the Microsoft download site. So with this, we move on to a small demo that I have here. So if you can see, I have three packages. The first one which says straight destination.dtsx. So I'll just go ahead and run this, and we will see that this moves around 1 million of data, 1 million rows of data pretty fast. So if I just edit this source component, I'll see that it brings all the rows from a table called test, and if I edit the destination, I'll see it pushes all the data in a target table called test1. So as we see, the package execution completed pretty fast, and it took little more than 22 seconds to execute. Please note that this is a very simple package, and typically a business, a real life production package will have a lot of complex transforms within it and will not be this simple. So to simulate a problem scenario, I have this second package called the problem.dtsx. So it takes a while to run, so let me just start the execution here. And if you see, I have the same source pulling all the records from the same source table, and it pushes all the data to the same destination table as well. The only difference that I have in this second package when I compare it with the first package is the transform in between. So for this demo, I do not have any complex real life transform, but I have created a script component, and if I show you the code for the script component, what we will see is that we have just put in a wait for a little more than 32,000 milliseconds, so that the pipeline waits when it goes through this transform component. In a real life scenario, this could be any transform that takes time to execute, for example a sort or an aggregate transform. So as we see, this time the package is taking more time to execute, and that is expected. That is because of the slow transform that we have in between. So for every row in every buffer that goes into this transform, it applies a delay for 32,000 milliseconds and then pushes the buffer to the destination. So this could be an example of a real life production package with a number of slowly performing transforms in between the source and the destination task. So we will wait for a while till this completes. As we can see, it is gone over around 700,000 records at this time. If I go to the progress tab, I'll see that it's still executing, and we can see that the execution time has well exceeded the previous execution time for the straight destination package that we had. So let's wait for a few more minutes here till this package execution completes. So we can see that the source has finished pushing all the data to the transform as of now. Actually, it's still waiting for a few more rows here. So yeah, now it has finished pushing the 1 million records to the transform. The transform is still processing its last buffer before actually writing it to the destination. Okay, so now the execution is complete. I'll stop debugging, go to the execution results, and if I check the execution time, I can see it's well over 2.5 minutes. So with this slowly performing transform in between, the same package operating on the same result set is taking 2 minutes 30 seconds in compared to just 22 seconds for the previous package. So now we move on to our solution, that is the BDD concept package. So if you can see now, we in between these two transforms we have the BDD component in place. So I'll just again go ahead and start execution. It may take some time, and as you can see, it operates on the same source table again, the test table, and instead of pushing it directly to the transform, we now have the BDD component in between. So as you can see, this BDD component has two outputs, and these two outputs send two buffers to the slow transforms. So if I again bring up the transform code, I'll see the same spin wait delay of around 32,000 seconds in each of these slow transform components. So we see the same spin wait here, and if I just edit the other transform component, I'll see the similar spin wait delay of 32,767 seconds. So in a series of tests performed in our labs, we found that these transform scales well up to 5 outputs. As you can imagine, this offers best possibility of upward scaling, and as much as using 5 outputs may not be the most optimum in a typical scenario, we should start with fixed load, increasing the outputs gradually, and experiment to eventually find the sweet spot. Okay, so I'm just trying to edit this script component here. It's working a bit slower since the package execution is in progress. So we see the same delay in here as well. But the only difference is, see that the package has already completed its execution. If we go to the progress tab, we see that it took only 1 minute 44 seconds, primarily because now we have simultaneously processed two buffers at a time using the BDD component, which now has two output paths, and it's just handing on two buffers simultaneously to the transform. And if we look at the destination, the interesting thing is that destination 1 pushes to the test1 table, and destination 2 pushes to the same test1 table as well. So in this video, you learned how to leverage the balanced data distributor component to increase the throughput of a package that has really slow transformations in it. You also viewed a demonstration where we saw how the BDD component drastically reduced the execution time of a package having a slow performing transform. My special thanks to Carla and Srikanth and to the entire user education team for getting this video done. I hope that you would find this video helpful and return to the SQL Server video series to watch other SQL Server videos. Thanks.